All right, let's talk about speed. In the world of industrial automation, things happen in the blink of an eye. So how do you control an action that needs to happen in one single perfect instant? Well, today we're going to zero in on a tiny, incredibly fast instruction that honestly makes all of modern manufacturing even possible. So here's our game plan. We'll start with the brains of the whole operation. Then we'll uncover a problem that happens faster than you can blink. After that, we'll find the solution by, you guessed it, catching the edge. Then we'll actually build out the code to see how it works. And finally, we'll connect the dots and see why this one little instruction has such a massive impact on everything. Okay, first things first, let's look at the big picture. You know, behind almost every single product you touch, there's this hidden brain, a powerful little computer making sure every step of the process happens exactly right every time. They're called programmable logic controllers, or PLCs for short. Seriously, think of them as the invisible command centers running the modern world. They started out as these clunky mechanical things, but have evolved into these super sophisticated computers that make millions of decisions every second just to keep things moving. Now, let's zoom in on a really fascinating challenge that these PLCs have to deal with. See, they are so unbelievably fast that a simple human action, like you pressing a button, seems like an absolute eternity to them. And here's why. A PLC is never, ever still. It's constantly running in this high-speed loop called the scan cycle. It reads the inputs, runs its program, updates the outputs, and then does it all over again, thousands of times a second. It's just relentless. So this super fast scanning creates a really specific problem. I mean, think about it for a second. If you just press a button, even for what feels like a quick tap, how many times do you think that PLC actually sees that signal? The answer is thousands. It's kind of wild, right? If one scan cycle only takes a couple of milliseconds, your 1-second button press isn't a single event. To the PLC, it's a continuous on signal that it sees over and over and over. And if your program is supposed to say, count one box for every button press, well, you've got a huge problem on your hands. This little flowchart here just nails the dilemma. The PLC sees the button is on, boom, it adds one to the counter. The very next scan, just milliseconds later, the button is still on, so it adds one again. This just keeps happening as long as your finger's on that button. So we need a way to tell the PLC, hey, ignore the fact that the button is on. I only care about the exact instant it was first pressed. The solution then is all about a shift in perspective. We have to stop thinking about the state of the button, on or off, and instead start focusing on the event, that one specific moment it changes. As Tech Talk Lilatesh puts it so well in our source material, every time you press and release a button, you're creating a pulse. And that pulse has two really important moments. The instant it goes from off to on, which we call the rising edge, and the instant it goes from on back to off, the falling edge. And to capture these precise moments, programmers have two special tools in their toolkit. The first is the one-shot rising, or OSR. It fires for just a single scan cycle the exact moment a signal shows up. And its partner is the one-shot falling, or OSF, which does the exact opposite. It fires for one scan cycle the moment that signal disappears. Okay, enough theory. Let's see how this actually works inside the PLC's code. We're going to build the logic right from our source tutorial, step by step, and watch how one single button press can kick off two totally separate actions. Okay, first we create a line of code. Programmers call it a rung. We take our input button and wire it up to an OSR instruction. Now this instruction needs its own little piece of memory called a storage bit, basically to remember what the signal was doing last time it checked. That's how it knows a new edge has arrived. And here is the magic. The very instant our input goes from off to on, that OSR instruction fires for just one tiny microscopic scan cycle. And then it's done. It turns right off, even if you're still holding the button down. It has perfectly captured that rising edge. So what's next? Well, on a completely new line of code, we use that very same input button again, but this time we connect it to an OSF, a one-shot falling instruction. And just like its buddy the OSR, it gets its own unique storage bit to do its job. Now this instruction is patient. It does absolutely nothing when you press the button. It just sits there and waits. But the moment you let go, the instant that input signal goes away, the OSF instruction fires its output again for one single scan. It has captured the falling edge. And just look at what we've done. With one physical button, we've used the OSR to trigger something right at the beginning of the signal, and the OSF to trigger a totally different thing at the very end. That is just incredibly powerful. So let's zoom back out. We've seen how this works in a couple of lines of code, right? But why does this tiny little instruction matter so much in the real world? In a word, everything. Honestly, without the ability to detect a precise instant in time, an edge, modern high-speed automation would be a chaotic miss. It would be unreliable, if not totally impossible. One-shots give us the precision we need to control things that happen faster than our brains can even process. This is why they're so critical. One-shots are the key to counting products whipping by on a conveyor belt. They let us log data the very instant a valve opens. They let us build safer machines where a reset only happens when a button is released, not just pushed. At the end of the day, they are a fundamental building block for pretty much any complex, automated sequence you can imagine. And the main takeaway is summarized perfectly right here. If you want something to happen when a signal arrives, use a one-shot rising. If you want it to happen when that signal goes away, you use a one-shot falling. It's that simple. It gives you absolute control over the beginning and the end of any event. And that leaves us with one final thought to chew on. This one simple instruction gives us the power to manipulate a single moment in time, a single scan of a computer. It kind of makes you wonder, doesn't it? What other elegant, invisible lines of code are out there quietly shaping the complex, automated world all around us?
Namaste. Thanks for watching. Stay tuned for more.